Okay, that signals our start. Our next video lesson is on absolute values. Our learning goal is to understand the absolute value function and expressions by taking a closer, more in-depth look. So I'm actually going to tell you for this lesson what the absolute value does, not just that it makes anything positive, because that's not really true. Excuse me. So far we've examined what this graph looks like and stated that it essentially makes any number positive, but what does it really do? The absolute value function takes the distance away from zero, where the direction does not matter, just how far away from zero it is. So you can't, because we're talking about distance and not displacement, which is different for the physics kids, because it's distance, you can't have a negative. It's just how far, how many units away from zero are you? So we're going to start with some warm-ups here. So we want to do the absolute value of 2 plus 5 minus 10. So you do what's inside the absolute value bars first, which would become 2 plus 5 is 7 minus 10, negative 3. So that's the absolute value of negative 3, which, yes, I've told you simply make the number positive, but now under our actual real definition, how many units away from 0 is negative 3? So if you think of a number line, put negative 3 on there, how far away is it from 0? Well, it's 3 units away. So that's why our answer is 3. Our next warm-up, put these in order from lowest to highest. So instead of thinking of these in terms of just making them positive, we're going to think of them in terms of how close are they to 0. So from lowest to highest, meaning closest to 0, going all the way to furthest from 0. So the closest to 0, hopefully you are thinking, is the absolute value of 1. The next closest to 0, negative 2, it's only 2 units away. The next closest to 0 would be 4. And the furthest from 0 would be negative 5. And hopefully that helps provide you some insight into what the absolute value actually does. Now we're going to do a bunch of things with the absolute value. For our first example, we're going to express each on a number line and as an inequality, if possible. So for A, the absolute value of x is less than 4. What this is asking you is, for what values of x are they less than 4 units away from 0? Let's start it with our number line. And we should always put 0 at the middle because that's what really matters. So there's 1, 2, 3, 4. Put a fifth one. 1, 2, 3, 4, 5. Negative 4. And then you're going to want to take out a different color. So let's take out a different color here. We'll use blue. Maybe we'll use a highlighter too. So less than 4 units away from 0. So if you start at 0, work your way to the right, 1, 2, 3, and then we hit 4. If you were to go one more beyond 4 to 5, that is not less than 4 units away from 0 anymore. You would be 5 units. In fact, if you went like 4.0001, that's a little bit bigger than 4. That is not less than 4 units away from 0. Since this is less than, you have to recall that you are going to use an open dot. So we're going to use an open dot at 4. And then if you go to the left and you count over from 0, 1, 2, 3, 4, and you get to negative 4. anything between 0 and -4 is less than 4 units away from 0. If you were to go beyond -5, you're now 5 units away from 0, so that doesn't count. If you were at -4.0001, you're a little bit beyond -4, you're a little bit bigger than, or a little bit beyond 4 units away from 0. So we're going to have another open dot at -4, and then anything in between those is a solution. So there's our solution on a number line. Anything between -4 and 4, not including those numbers, is less than 4 units away from 0. We also want to express them on as an inequality. So how do I express something between -4 and 4 as an inequality? It's kind of like doing the domain. So that would be -4 is less than x. We're not going to be equal to because it's not a closed dot. Is less than 4. And once we do a few more examples, it hopefully, if it's not sinking in, it hopefully will. Now we want to pick, so B, we want all the numbers that are greater than or equal to 7 units away from 0. Start with our number line. Put 0 in the middle. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This one's the opposite. So anything that is, if we start at 0 and go to the right, anything from 0 to 7 is less than 7 units away. And we want it to be greater than 7 units away. And since this is equal to, we're going to use a closed dot. And anything 7, 8, 9, 7.1, whatever it happens to be, those are all greater than 7 units away from 0. Likewise on the left, anything between 0 and -7, that's less than 7 units away from 0. We want it to be greater than, so we want it to be more than 7 units or equal to. And going out this way. And we want to also express this as an inequality. Now there's no way you can do something like this that has 2 separate pieces going in opposite directions, neat and tidy like we did A. So you just express it with 2 separate inequalities. So on the left, anything that is less than or equal to -7 is one possible solution set. And the other would be anything that is greater than or equal to 7. And this goes with this, and this goes with this. And we're using the equal to's on the bottom of our inequalities because it's closed dots. Next one, C. We want anything that is less than or equal to 5 units away from 0. Start with our number line. Put 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we want it to be less than or equal to, so less than or equal to 5 units away from 0. Well, that's going to be like A, it's going to be between -5 and 5. And the difference is, since it's equal to, we're going to have closed dots. And anything between those 2 points is going to be less than 5 units away. So just connect those. As an inequality, just like A, -5, less than or equal to, less than or equal to, +5. D, something that's more than 3 units away from 0, number line, 0, and then 1, 2, 3, 4, 1, 2, 3, 4. And we want it to be more than 3 units away, but not equal to. So it's going to be open dots and pointing out to the left and pointing out to the right. So open dot, pointing out that way, and another open dot pointing out this way. inequality, just like B, it's going to be two separate pieces. And we're not going to use equal to's since it's open dots. So for this first piece, any x that's less than negative 3. And for this piece, any x that's greater than 3. And that goes with that, and that goes with that. Hopefully that makes sense. Our next example, we're going to be working the opposite direction, or one of the other ways. Express each in absolute value notation. And we're going to assume that those are open dots. So let's call this A and call this B. For A, we want everything that's 2 or less units away from 0 is what that line means. So you could look back at our first example, but we want absolute value of x has to be 2 or less units away. Not including because they're open dots. So absolute value of x is less than 2. B, this first piece on the left, it's at negative 3, and it's more than 3 units away. The piece on the right is at positive 3. I'm pointing outwards, anything bigger than 3 away. Open dots, absolute value of x greater than 3. C and D. So this is the final way. I'm giving you now the inequalities, and you have to express them as absolute value notation. Oh, there's that bell interrupting me again. So we want, if you had the inequality, x is less than negative 4, so that would be negative 4, negative 5, negative 6, that's 4, more than 4 away from 0. And then x is greater than 4, 4, 5, 6, that's more than 4 units away from 0. Since they don't have the equal to signs on them, it would be x, and we're more than 4 units away, greater than 4. D, it's between negative 5 and 5, which means 5 or less units away from 0. Absolute value of x, and again, less than or equal to 5 units away from 0. So that's the 3 ways, and they're all, you should be able to go from one to any of the other 2, which we've just practiced. Our next example is going to take it up a little notch here. So we're going to start solving these. So we want to know what value of x is equal to, or is going to make something equal to 3 units away from 0. So if you want to think of this on a number line, right? If we think of this on a number line, which you don't have to do this as a part of your solution, it just helps show you that there could be more than one case, which there's going to be more than one case for these. So there's 0. And we know the absolute value means how far away from 0 you are. So we want some value of x that will make us 3 units, exactly 3 units away from 0, which means we want a value of x that 1, 2, 3 units away that way. But we know that we could also be 3 units away to the left. 1, 2, 3. So that's kind of like case number 1, and that can be case number 2. So to organize our solution process, case number 1, I'll pick the positive one. So x plus 2 has got to equal positive 3. Simple solution, x equals 1. Case number 2. Well, I got to be equal to, case number 2, I could be negative 3, because negative 3 is also 3 units away from 0. So x plus 2 equals negative 3. Bring over the 2 becomes negative 2. Negative 3 minus 2 is negative 5. So So this has two solutions. X can be 1 or X can be negative 5. Another way to think about this other case, if you don't think of it on a number line, is going back to kind of our simplistic idea of what an absolute value does, makes anything positive. So once you get case number 1, which is the easy one, just straight up x plus 2 equals 3, the negative version of that would also, if you think of it in terms of being made positive, if I turn what's inside the absolute values negative, that would also turn it into a positive in quotations, even though you can't see my air quotations. Remember, that's just our simplistic definition, not actually what it does. So you could also think of this like this, with a negative out front. If we think of our simplistic version, anything negative from the absolute value will turn into a positive. And how do you get rid of that negative? Divide both sides by negative 1, and you're left with x plus 2 equals negative 3. Obviously, we're going to get the exact same solution. Just a matter of what works for you for thinking about it. B, we want a value of x, so x plus 2 has got to be greater than or equal to 4. In other words, it's got to be 4 or more away from 0. Again, if you want to think of this on a number line, 4 or more is that could be like our case number 1, and negative 4 going that way. That could be like our case number 2, more than 4 units away from 0. Case number 1. And if you're thinking, do you have to rate case 1 and case 2? I would say the answer is yes. You should show me what you're doing. So x plus 2 has got to be greater than or equal to positive 4. Working with inequalities is the same. Treat them like equal signs. So bring the 2 over, becomes minus 2. 4 minus 2 is 2. So there's one solution. Case number 2. X plus 2. Now, since we're going to the left, right, that's case number 2, if you look at your number line, that's going to the left more than negative 4, negative 5, negative 6. That would be less than or equal to negative 4. Bring that 2 over, still becomes negative 2, negative 4 minus 2, negative 6. So there are our two solutions. Just like I showed you over here, again, I'm going to do this just in case this is someone that prefers this for case number 2. You could think of it as the negative version of case number 1. So again, x plus 2, but make it negative. Same thing as the example A, divide both sides by negative 1, but here's the catch. When it comes to inequalities, whenever you divide by a negative, the inequality flips. So we're going to make a note there. So when you divide by a negative, which my short form for negative, by the way, is that, divide by negative, inequality flips. And what that means is it's now greater than or equal to, it's going to flip. So it's going to become x plus 2, and this is going to flip to that. And we're at the exact same thing. Bring the 2 over, becomes negative 6, and the exact same solution. So really up to you. Getting a little bit trickier here as we go. So now we want less than or equal to 17 units away. So this one's a little bit harder to think about on a number line, but we can still do it. So let's do this. There's 0, there's 17, there's negative 17. And if we want to be less than 17 units away and equal to, this right here is kind of going to be like our case number 1. And then this right here is going to be like our case number 2. So those are going to be going into each other. And remember, this is going to give us a solution set between two numbers. So case number 1. Since I'm going to the left, it's less than or equal to 17. So 3x minus 1 less than or equal to 17. Bring the negative 7 over. Sorry, negative 1, not negative 7. Bring the negative 1 over, becomes positive 1. 3x is less than or equal to 18. Divide both sides by 3. X is less than or equal to 6. Case number 2. Well, that would be the other side, which would be greater than negative 17. Because we're going to the right. So 3x minus 1 could be greater than or equal to negative 17. Bring over the negative 1, becomes positive 1. 3x is greater than or equal to negative 16. Divide both sides by 3. X is greater than or equal to negative 16 over 3. I'm not going to do the other way, like in terms of thinking of as negatives. I've just shown you twice. If that's your preference, you can do it. You'll get the exact same answer as we do here. Now remember, since this is a less than absolute value, there's going to be an overlap. So those arrows are pointing in at each other. There's going to be an overlap. So those aren't just two solution sets like that because they're pointing in opposite directions. So you have to go with your lowest, which is negative 16 over 3 is less than or equal to x is less than or equal to our largest number, which in this case is 6. And there's our solution set. Now D. This one's a little bit trickier to think about it on a number line because we've got absolute values on both sides. So here's going to be an instance where I actually do treat it like the simplistic version, just the negative case. It's doable on number line, but it's confusing, so I'm not going to do it that way. So case, actually I'll use a different color here just to contrast the red. So case number 1 could be 5x plus 8 equals 2x minus 1. Bring over the 2x, becomes negative. 5x minus 2x is 3x. Bring over the 8 becomes negative. Negative 1 minus 8, negative 9. Divide both sides by 3. X equals negative 3. There's one case. Case number 2. Again, we're going to treat it like the negative version, just the simplistic idea. How you deal with this is up to you. You could divide both sides by negative. You could distribute the negative in. Since I've already done the divide both sides by negative, this time I'll just distribute, change it up, keep it fresh. Negative 5x minus 8 equals 2x minus 1. And if you divide both sides by negative 1, you'll get the exact same final answer. And bring over the 2. Let's say you want to keep things on the left, or your variables on the left. That would be negative 5x minus 2x is negative 7x, and that would become negative 1 plus 8, which is 7. And divide both sides by negative 7, x equals negative 1. So there's two solutions. Now if you're thinking, maybe some of you are thinking, there's two sides with absolute values, so technically there should be 4 cases. Well, let's examine that. Okay, so case number 3. Well, we could have the positive version of the left-hand side equal the negative version of the right-hand side. And if we divided both sides by negative, let's say, you would have negative 5x minus 8 equals 2x minus 1. Well, we've already done that case. We already have the answer to that. So we don't have to worry about this. We're going to have the same answer. And then case number 4 technically would be both negative versions, because we know absolute values, again, the simplistic idea is they become positive. So we can make negative 5x plus 8 equal negative 2x minus 1. Well, if you divide both sides by negative, two negatives make a positive. You're right back to case number 1. Don't have to worry about this one either. So hopefully that does make sense. Sorry about the bell interrupting me again. Hopefully that makes sense. And again, if you see a question like D in the future, you don't have to worry about doing 4 cases. You can just do 2, and I just proved to you why case 3 and 4 end up with the same solution as case 1 and 2. For our final example, I'm actually going to get you on your own. So I'm going to say this is a you try on your own example. We haven't seen anything like this. There's one additional step. So I'll do the additional step with you. And then after that, that'll give you all the right head start. And then I want you to do it on your own. So we haven't seen anything where like there's the negative 7 beside the absolute value. Easy to deal with. Move it to the other side. Becomes positive 7. And we are left with this, 27. So now that we all have the same starting point, I want you to split it up into case number 1 and case number 2. And I want you to try this on your own. So try this on your own, and then I'll come back and just give you the final answer, and you can see if you did it correctly. So away you go. If you're still not done, that's okay. Pause. Hopefully for one of your cases, you got x equals negative 4. And for the other case, you got x equals 5. If you didn't, go back, check what you did. Phone a friend maybe, or ask me. There's your seat work. Page 16, 1-6, handout. I haven't posted the handout on D2L yet. I'm not sure if I'm going to. If I do, you'll see it. If not, just focus on the textbook work. And again, there is your test review page and questions. So you only have one more lesson, and I currently have that scheduled to be done Friday morning, first thing. And then you'd have some more of the morning to do some review and your test in the afternoon. By all means, I mean, I've said this before, you guys are in charge of your own learning. If you're ahead of the game or you have some extra time and you want to watch lesson number 9 on complex numbers, if you want to watch that Thursday night and then have all of Friday to review before your test, that's up to you. And then I'm going to be posting another video that I'm going to recommend that everyone watches that just goes over the expectations of the test, maybe in a bit more detail, and listening to me as opposed to reading it in an email.